Hi guys, this is your review for your quiz tomorrow on Unit 5, which is on systems of equations. The way I like to do my review is I like to work one of every kind of problem that you're going to see tomorrow on your quiz. And then what I like to let you do is to use this paper as a cheat sheet on the quiz tomorrow. So please make sure that you're taking really good notes today on this paper, not only because Mr. Miller is going to give you some points at the end of this today, 10 points for following along with me and filling out this sheet, but also because tomorrow you get to use this on the quiz. So this first problem right here is set up for the elimination method. I can tell just by looking at it, because if I take these numbers right here, the 4x and the negative 4x, and I add those straight down, they're going to cancel. So I don't have to multiply these equations through by anything or do anything fancy to them. I'm just going to add those two equations straight down and get my solution. 4x minus 4x is 0, so I don't have to show any x's there. 8y plus 2y is 10y. And then 20 minus 30 is a negative 10, or 20 plus a negative 30, however you want to say that. When I added straight down there, I got one of the variables to cancel, which is how the elimination method works. And so then I just need to continue to solve it for the variable, in this case, the y. So to get y by itself, I'm just going to simply divide both sides by 10. That's going to get y by itself. And I get y equals negative 1, because negative 10 divided by 10 is a negative 1. So now what I'm going to do is I am going to substitute that value back into one of the two original equations to solve for the other variable. Because anytime I'm solving a system of equations, I need an ordered pair for my solution. So I'm going to come up here and I'm just going to rewrite that top equation. 4x plus 8y equals 20. And I'm going to substitute this number, negative 1, up in here in place of the y. So I'm going to go 4x plus 8 times negative 1 equals 20. And I'm going to continue to solve that. That would be 4x. This multiplies to be a negative 8, so minus 8 equals 20. Now my goal is to isolate the variable. I need the x by itself, so the first thing I'm going to do is add the 8 over to the other side. I get 4x equals 28, because 20 plus 8 is 28. Still continuing to isolate the variable, get rid of the 4 by dividing it to the other side. Cancels on this side to x. And then on this side, I get 7. So if my x value is 7, it's the first part of my ordered pair. My y value is negative 1. My solution is that ordered pair, 7, negative 1. All right, let's take a look at this next problem right here. This one is set up for elimination method also, because you can see the x's are lined up right here. The y's are lined up, and it's equal to the constant numbers on both of them. Anytime we have our equation set up like that, usually the easiest way to solve them is by the elimination method. If I notice these, though, the way that they are, if I were to add them straight down, I would get some x's here, and I would still have some y's here. So I can't just add them straight down and have them cancel. But what I am noticing here is that I have a positive y here and a positive y here. If I can get one of those y's to be a negative y instead of a positive y, then I can actually add straight down and cancel. So how do I get it to be a negative? I multiply through by negative 1. So I'm going to choose to multiply this bottom equation through by negative 1. And then I can add straight down. So negative 1 times a negative 3 is a positive 3x. Negative 1 times y is a negative y. And negative 1 times negative 5 is a positive 5. Now when I do this, I like to just kind of cross through the equation that I'm not going to use anymore, so I don't forget what I'm doing. Then I know I can just add straight down with the equation that I have left. So 8x plus 3x is 11x. My y's are gone. That's why I multiplied through by the negative 1, so I could get those to cancel straight down. And then I have a negative 16 plus 5, which is a negative 11. Continue to solve this for x, so I'm going to divide that 11 to the other side, and I get x equals negative 1. Now, it would be nice if I was done right there, but I'm not. In order to continue to solve this, I need to solve for my y value also. So I'm just going to come up here, and I'm going to pick one of my original equations, which is easy to see that top one. The 8x plus y equals negative 16. And I'm going to substitute in this negative 1 right here in place of the x. So it'll be 8 times negative 1 plus y equals 16. 8 times negative 1 is a negative 8. So negative 8 plus y equals 16. Then just continue to solve this by adding that 8 over to the other side. And before I go any further, I noticed here that I lost my negative on my, I had a negative right here, but I forgot to carry it down. So let's just go back and add that negative on here so I don't mess up right here. There should be a negative right here. So when I add this 8 to the other side, it would be a negative 16 plus 8, which is a negative 8. So if my x value is negative 1 and my y value is negative 8, then my ordered pair solution would be negative 1, negative 8. All right, same thing on this one. It's set up for the elimination method. I can tell because everything's lined up together. When everything's lined up like that, I'm going to see if I can add them straight down. If I can't, I'm going to multiply one of them through by a number in order to add them straight down. If I try to add them straight down the way they are not going to cancel. So what I need to do is look at it and decide if I'm going to get rid of the x's or get rid of the y's. I think it kind of doesn't matter on this one. It's about the same amount of work no matter what. But I do like the way that these y's look right here. So I think if this one's a negative 2 right here and I can get this to be a positive 2, then that's the way I want to go. And in order to get that top one to be a positive 2, I would multiply that equation through by the number 2. So I'm going to multiply that top equation by 2 and just rewrite the equation. So 2 times 5x is 10x. 2 times y is 2y. And then 2 times 9 is 18. I'm not going to use this equation anymore right here because that's the one I multiplied through by. So I'm going to use the other equation and the one I just rewrote, and I'm going to add those straight down. The x's cancel here because 10x and a negative 10x cancel. The y's cancel right here. And the 18's cancel. So here's what I've got left over. I have nothing on this side equal to nothing on this side. When that happens and I get 0 equals 0, which happens to be a true statement, the solution to this is many solutions. You've maybe have heard it as many solutions. You've maybe heard it as all real numbers, like a capital R like this. And maybe you've heard it as infinite solutions. Any of those that you put would be proper solution names for this problem. So all my variables canceled and I got a true statement. When it's a true statement, that's when this answer, many solutions, occurs. All right, number 4, again, set up for the elimination method, meaning add straight down after I multiply through by a number. I kind of like the way the y's are looking. So if this is a 3y, I need this one up here to be a negative 3y. So I'm going to multiply the top through by a negative 3, and I'm just going to rewrite that equation. I'm going to rewrite it down below. So negative 3 times negative 7 is a positive 21x. Negative 3 times y is a negative 3y. And a negative 3 times a negative 19 is a positive 57. I'm going to cross that one out again to remind myself not to use it, and I'm going to add straight down. I get negative 2x plus 21x, which is 19x. My y's cancel, which is why I did this in the first place. And then over here, a negative 19 plus 57 is a positive 38. I'm going to continue to solve for x, so I'm going to divide both sides by 19, and I get x equals 2. And it would be nice if I was done, but I'm not. I still have to solve for y, so I'm going to just rewrite one of my original equations. I'm going to use that top one I crossed through, so I have a negative 7x plus y equals a negative 19. And I'm going to substitute the 2 in place of the x. So negative 7 times 2 plus y equals negative 19. Negative 7 times 2 is a negative 14. So negative 14 plus y equals a negative 19. I'm going to add the 14 to both sides, and I get y equals negative 5. So my ordered pair solution is my x comma y. So 2 comma negative 5. All right, we're going to move on to the next problem. You guys, if I'm ever going too fast on this, which I might be because I'm trying to get through the whole review for you today, just pause this and talk about it and then just move forward after that. But let's move on to number 5. All right, this one is not set up for elimination. If you notice, my x's are not lined up, my y's are not lined up. So we know we're not going to try to use elimination here, which means I'm going to use a different method, and I'm going to use substitution. I can see y is equal to 6x minus 11, so what I'm going to do with that is I'm going to substitute it into the other equation in place of the y. So I'm going to go negative 2x and then minus 3, and then in place of that y right there, I'm going to put 6x minus 11, and then continue to rewrite the rest of this equation right here. So I'm going to have the minus 7 off the end. I'm now going to distribute that negative 3 through right there, and I'm going to solve that as I go by getting the variables by itself. So I'll have a negative 2x rewritten here, have a negative 18x from the 3 and the 6, then a positive 33 from the negative 3 times the negative 11, and then I still have negative 7. So I'm going to continue to solve this by combining like terms. Negative 2x and a negative 18x makes a negative 20x. So I have a negative 20x plus 33 equals a negative 7. My goal is to isolate the variable, so get that x by itself. So I'm going to subtract the 33 to the other side. So I get a negative 20x equals negative 40. Divide both sides by a negative 20. And I get x equals positive 2. And then I'm going to have to take that and substitute it back up into one of the two original problems in order to find my y value. So I'm going to go with y equals 6x minus 11. My goodness, I keep touching the wrong spot on my iPad here. And I'm going to put 2 in place of the x. So y equals 6 times 2 minus 11. 6 times 2 is 12. 12 minus 11 is 1. So y equals 1. And my ordered pair solution there would be 2 comma 1 because it's always x comma y. All right, one more of these kind of problems here. Again, this one is set up for elimination. I can tell it is because the x's are lined up, the y's are lined up, the numbers are lined up. So in order to get rid of one of the variables here, I just need to decide which one to get rid of. If I wanted to get rid of the x's right here, the top one's a negative 3x, so I need the bottom one to be a positive 3x. So I'm going to multiply through by a negative 3 to make that happen. Negative 3 times a negative x is a positive 3x. Negative 3 times a y would be a negative 3y. And a negative 3 times a 3 would be a negative 9. I'm going to cross through that one to remind myself I'm not using it when I add straight down. And I'm going to add negative 3x plus 3x cancels. 3y minus 3y cancels, which means I have 0 on this side. And then on the other side, 4 minus 9 is a negative 5. This is a false statement right here. Anytime my variable cancels and I get a false statement, my answer is no solution. And if you remember, an easy way to write no solution in mathematics is that 0 with the line through it. So you can either write no solution or you can go empty set or no solution with the 0 with the line through it. All right, next problem, find the y-intercept. Now this equation is in slope y-intercept form. So if we have it in y equals mx plus b form, the b value is the y-intercept. That's what it stands for in our equation. So this is in y equals mx plus b form here, and I'm looking for my b value for my y-intercept. So my y-intercept is the number 48. And that's really all I need to know. So if you're in the form y equals mx plus b, that b value will always be your y-intercept. Another way you could find that y-intercept is whenever you're looking for the y-intercept, you set x equals to 0. So you could take that and just substitute it into the equation. You could have gone y equals 6 times 0 plus 48. 6 times 0 is 0. And so y would be equal to 48. It would be the same either direction you solve it. All right, the next set says to find the x-intercept. Now, when we just did that last one and we found the y-intercept, we set x equal to 0. So when we're finding the x-intercept, we actually set y equal to 0. So what I want to do is I want to look through my table of values and I want to find the spot where my y is equal to 0, which happens to be right there. And then what I'm going to do is I'm just going to write my x value for my solution. So my x-intercept would be at x equals -3. So to find the x-intercept, you set y equal to 0. To find the y-intercept, you set x equal to 0. Okay, this next one is a graphing one. We're going to graph these two and see if we can find the point of intersection if there is one. So this first one right here, this is a horizontal line. I can tell because there's not an x value in it, which means there's no slope there. So what I'm going to do is I'm going to go up to y equals 4, so 4 on the y-axis. Again, this is the y-axis up here, so 1, 2, 3, 4. So I'm right here on the y-axis. And from there, I know I'm going to have this horizontal line across because everywhere my y value has to be 4. Then I'm going to graph this other one, which is in slope y-intercept form. The back number tells me where to start, which is up at 2. And then from there, I follow my slope. The number in front of the x here is a -1, so I would go down 1, right 1, down 1, right 1, down 1, right 1. And then I know that it's also going to go up 1, left 1 if I wanted to go that way. I didn't do a very good job drawing my graph through the ordered pairs there. But if I wanted to find that point of intersection, I would be over 1, up 1, over 1, up 1. Right here would be my point of intersection. That ordered pair would be -2, 4. So what I'm trying to do there is find that point of intersection from where those two graphs intersect. All right, this set right here of equations is not really ready to graph right now. I can do a couple of different things. I can find my y-intercepts and graph those ordered pairs, or I can solve them for y so that they're in slope y-intercept form and kind of graph them from there. I think that I'm going to just go with y and x-intercepts this time, seems that was part of this chapter, and see if we can go from there. So if I set x equal to 0 on this top equation, meaning the x is gone because 3 times 0 would be 0, then I get y equals 6. So I have one ordered pair there already, which is 0, 6, that I know is on this line. So that ordered pair right there is on the line. I'm trying to get that to be exactly where I need it to be. And then I would do the same thing with my y value. I would set my y value equal to 0 up here in this top equation, which means the y would be gone, and I'd have 3x equals 6. Well, I know 3 times 2 is 6, so my x value would be 2. So I have the ordered pair 2 comma 0, which is right here. And I know that my line is going to cross through those 2 ordered pairs. So negative 3 times 51 is the negative 153. So I'm not going to use that top one anymore. I lost my negative right here. Make sure I have that right. Because negative 3 times right here gave me a negative 3. Or a negative 9, I should say. And then when I add those straight down, alright, you guys, I am really sorry that I have made a mistake on this. When I wrote this down, I didn't write it down right. So I apologize that we have to go back and start this problem over because I wrote down the problem wrong. So please accept my apologies, but we're 20-something minutes into this and I really do not want to start over again. So stay with me on this and follow along with me. I'm sorry. So the original one was 3 adults and 11 children equals $51. When I wrote this the first time, I wrote 3 again. And then the second one was 9 adult plus 1 child equals $102. So those are my right equations. I should have checked the story problem again, so I'm sorry about that. Okay, so again, though, I still do want to get rid of those A values, and so I'm going to have to multiply through again by that negative 3 up on the top. So when I do that, I get a negative 9A, a negative 33C, and then still what I had before was the negative 153. This is looking more correct now. I'm not going to use that top equation because that's the one that I multiplied through. So the 9A's are gone. I get a negative 32C. And then over here I get a negative 51. To continue to solve that for C, I'm going to divide by a negative 32, which is my last step here. And if I round this to the nearest dollar, my child ticket is $1, or if I round it to the nearest dollar and cent, my child ticket is $1.59 each. All right. Let's try setting up the equations again one more time on this last problem, which is what the instructions say to do, write the set of equations. And I'm going to try really hard to write down the numbers that are actually in the word problem. So it says Davis and some friends went to see a movie. Davis spent $37 on 3 popcorns and 4 movie tickets. So we know that if he does 3 popcorns, we're going to call popcorns P. And 4 movie tickets, I'm going to call that an M. We know that he spends $37. So I can just write that equation, 3 popcorn plus 4 movie tickets equals $37. And then the second one says his friend spent $67. So 67's coming over here on 5 popcorns and 8 movie tickets. So 5 popcorns plus 8 movie tickets is going to equal $67. Now the instructions up here just said to write the set of equations, but after I kind of wrote that other one wrong, it makes me kind of want to just show you this one again to make sure you got it. But really what we could do is we could look at this and we could decide to get rid of our M values right here. And if we wanted to do that, if the bottom one is 8, I need the top one to be a negative 8. So I could multiply through by a negative 2 and just continue to solve this so that we could solve for the movie tickets and for the popcorn. So, but the instructions did not ask me to do that, so I'm not going to continue to do that. So again, you guys, just a reminder, make sure you check this off with your teacher today to get credit on doing this review page. And then please make sure that you keep this page for tomorrow, because tomorrow you can use this review page on the quiz that you're taking on solving systems of equations. So thanks for watching the video, and good luck on your quiz tomorrow.